Hello students, so today we are going to solve this resistance network problem where we can see there are 12 resistances connected in the form of a cube, and the question is what is the equivalent or effective resistance between the terminals A and B shown in the picture. So it is a very interesting and very classic problem. You can find this problem in any of the physics book. So let us see how can we solve this question. Let's start. So suppose I say the total current you send from point A to the network, that is I. Okay. So total I current is being sent to the network. Now you see at this lower corner here, I am trying to show here. So here the total current I will be divided in three parts. But if you look carefully, all the three paths are identical. If you reach at point B from point A, then you have identical paths. So it is symmetry. Like if you go from the upper branch, you get one resistance, then it gets divided into two branches, again two branches merge to reach at point B. Similarly, the inner branch, this resistance R, that is a single resistance, then gets divided into two resistance, then again two resistances and merge at point B. Similarly, the right resistance, that is single resistance, again divided into two resistance and again merging through two resistances at point B. So all the three paths are identical if you see from point A. So the current will also be equally divided. You are using the principle of symmetry. So the three paths are identical from point A, so you will divide the current equally in the three branches. So current in this branch will be I by 3, in this resistance also I by 3, and in this resistance also I by 3. Okay. Now again, after reaching the point, this point here, if you see the I by 3 current is reaching here, but again it will be splitted into two parts, and again you can see that the two paths are identical. Either way you go, one resistance then another one resistance, you reach at point B, again one resistance and another one resistance, you reach at point B. Both paths are identical, so this I by 3 current will again be divided equally in the two branches. So I by 3 will be divided in two parts, so it will be I by 6 and I by 6. So basically you are using the concept of symmetry here. If the two paths are symmetrical, two paths are identical, then current will be equally divided in those two paths. Similarly, the other two currents I by 3 also, they, because of symmetry, they will equally get divided, I by 6 and I by 6. Similarly, this I by 3 also, here I by 6 and I by 6. Now let us come to point B and see what current is returning back to point B. So if we see here, what is the current here? So you can see I by 6 is coming this way and I by 6 coming from lower branch. So those two I by 6 and I by 6 will make total I by 3, right? So okay, so I by 6 plus I by 6, that will become I by 3. Similarly, if we look at this point here, so here I by 6 is coming and again I by 6 is coming from here, they will make I by 3. And similarly, I by 6 coming from here, I by 6 coming from here, so total current here will also become I by 3. So due to symmetry, you can see that from point A, in the three branches, the current went I by 3, I by 3, I by 3. And if you look at point B also, the current in three branches returning back to point B is I by 3, I by 3, I by 3. So this is the beauty of symmetry. Okay, so we had to find the total resistance between points A and B. So in this question, you can't divide the resistances in parallel or series combination. So it is not like series or parallel combination, or you could directly use series parallel formula, or you can calculate the resistance. So this kind of questions you can't do like that. You need to use the basic concept of symmetry and basically Ohm's law. So suppose we move from point A to point B. Now we are going to use KVL. I hope you know KVL is also known as Kirchhoff's voltage law, that is full name, or sometimes it is also called Kirchhoff's mesh law or Kirchhoff's loop law. There are many. So we are going to apply Kirchhoff's voltage law from point A to point B. And I would like to remind you that if you move in the direction of current, then the potential drops. So it is basically principle that current always flows from higher to lower potential. So suppose we start from point A and potential at point A is VA, then you can choose any path, right? You can choose any path from A to B. So let's say we choose this path. You can choose any path. You choose this path, and let's start moving from point A. So potential at point A is VA, and then we are moving in the direction of current, so potential will drop. And how much potential drop will take place? I into R using Ohm's law. So VA minus I into R for this first resistance, the current is I by 3 into resistance is R. Again you get another resistance, there the current is in this resistance. In this resistance the current is I by 6 and resistance is R. So it will be I by 6 into R. And further at last this resistance, current I by 3 and resistance R. So I by 3 into R, and total the remaining potential will be the potential of point B. So it will be VB. So from here you can write VA minus VB, that will be I by 3 plus I by 6 plus I by 3, and R will be common in all of them. So from here you can write 6 will be the LCM, 3 2 is 6 plus 6 1 is 6 plus 3 2 is 6 into R. So basically it is 2 plus 1 3 plus 2 5, so it is 5 by 6 R VA minus, and I will also be there, right? Yeah, here I will also be there. So it is I into R, VA minus VB equals 5 by 6 I into R. And if you see, if we take this total resistance network as a black box, if you don't know what is inside that, and you know the potential difference VA minus VB, and total current it is taking I, so what will be the resistance using Ohm's law? That will be potential difference VA minus VB divided by I, right? So our total resistance of the circuit network is total potential difference divided by the current. So VA minus VB upon I, and from this above step we can write VA minus VB upon I is equal to 5 by 6 R, or from here we can write this VA minus VB upon I, that is the effective resistance between points A and B. So R equivalent resistance is 5 by 6 R, and that is the answer to this problem. So I hope you would have enjoyed this question. This was a very classic and very nice question of electrical circuit resistance calculation. So see you again next time with another problem. Take care then, and bye bye.